Hey, today we're taking a look at atomic mass. So, some of you guys might be remembering our last unit was on the mass number. And you might think, what's the big difference between atomic mass and mass number? Well, a quick review, mass number we found by adding the number of protons and the number of neutrons in an atom. And mass number provides us a way to distinguish between the different isotopes of an element. So, for example, there's the mass number. For the 3 carbon isotopes, we have carbon-12 isotope. This tells us we have 6 neutrons. Carbon-13 isotope with 7 neutrons. And carbon-14 isotope with 8 neutrons. Atomic mass is a little bit different. Atomic mass is the weighted average of all the isotopes of an element. So atomic mass is the number listed in the periodic table. So you have a periodic table. Here's carbon, for instance, and that number, the decimal behind it, that is your atomic mass. Just like the mass number, the atomic mass is measured in what we call AMU, which are the atomic mass units. Okay, a weighted average. A lot of times people get a weighted average confused with the regular old average. I'm sure we all know how to do an average. If you hear that the scores on a test were a 50 out of 50, and a 0 out of 50, we could all find that average pretty simply. You add the two numbers together, you get a 50, and you get a 0, and then you divide by the total number you have, in this case 2. You end up with a 25 out of 50, a 50%. That's not a very good average. A weighted average is a little bit different. In a weighted average, you use a percentage. So 95% of the students scored a 50 out of 50 on the test, and 5% of the students scored a 0 out of 50. That's going to change our numbers a little bit. So our weighted average, what we do is we take our score, 50 out of 50, and multiply it by the percentage of students that scored that amount. So 0.95, make sure you convert that percentage into a decimal. Then we add the 0 out of 50 that the 5% scored. Again, make sure you convert that 5% into a decimal. You add those two values together, and now we see the class average was a 47.5 out of 50. That's a lot better. So a weighted average takes into account what we call the relative abundance of an isotope when we factor in the average. So that relative abundance is how frequently a given isotope is found in nature. And it's usually going to be listed as a percentage. So it's going to be a lot like the example we worked on up above. Let's take a look at an example. So what is the atomic mass of silicon? If 92.21% of its atoms have a mass of 27.977 AMU, 4.70% have a mass of 28.976 AMU, and 3.09% have a mass of 29.974 AMU. Okay, well, this equation is the relative abundance, that's the percentage, of the first isotope times its mass. That'd be right there. So here's our first relative abundance. Here's our first mass. We're going to add that, so here's the plus sign, to the relative abundance of isotope 2. So the relative abundance, that's the percentage, the 4.70 percentage, and the mass of isotope 2, which is 28.976 AMU. And finally, the relative abundance, in purple here, 3.09%, times the mass of isotope 3, 29.974 AMU. So we multiply those all together. Here we are. And then we add them up. Make sure you show this second step. For significant digit purposes, our numbers are going to change. Our significant digits are going to change at the end there. So don't skip this step. Do each step, do the 0.9221 times 27.977 and list that value out. Make sure you underline your extra digits. See, my extra digits are underlined here. I should only have 4. And indeed I do, 25.79. I'm not rounding the 7/6 off yet, otherwise I might get what's called round off error. So I keep those extra 2 digits, but I underline them to show that they're not significant. Now we have an addition problem. Addition problems are different than multiplication. That's the idea of a mixed operation problem. So now that we add these up, we have to change our digit rules. It no longer matters how many we have, it matters where the last one is at. So this one goes to the 10th hundredths column. This one goes out to the thousandths column, but it's not going to matter because the two previous went on to the hundredths column. So when we add these up, our final answer should go to the hundredths column, 28.09 AMU. Watch your units as well.